Hi, good day all. So this should be video number 7 inside the series. Lab number 7, be looking at vectors. So I know this one might be a little bit longer, but nonetheless we are going to take a good crack at it. Now vectors, remember what's a vector? A vector quantity is a quantity with magnitude and a direction. And the way that we represent vector quantities is that we could use an arrow. So what is the difference between vectors and scalars? So say for example, we got your mass. We simply represent your mass as 6 kilograms. What about if you were running a race? All right, so you're running a race, and maybe this is just a big playing field. Everybody be like, oh, and this is the finish line right here. Whoa, this is the finish line right here. Ba, 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 bam. And this is where you start. And nobody knows where the finish line is. And a whole bunch of y'all just standing up like, where do we go? Where do we run to? And the person's like, over there by the big tree. All right, but the big tree is where we're going to go. So immediately you're starting to point your direction. When you say, "Hey, my mass is is 66 kilograms," no one's like pointing where. It's like right here. We know where your mass is. But if you're running a race and you're going to have some velocities, you're going to be running, you're going to have some acceleration. It's always going to be like, where do you want me to accelerate? Where do you want me to move my feet? Where do you want me to apply my velocity? All right. Where do you want me to have my momentum going? All right. Where do you want me to apply such a force? And this is the whole concept of vectors, in that there needs to be a direction when it comes to certain quantities. Mass, not so much, not a vector, but running, which has a velocity, well, you're gonna be like, where do you want me to go? And how do we represent where? Well, whenever you are wondering where to go and you want some directions, you point. All right. So how do we represent pointing on a piece of paper? Is that we can use an arrow. And guess what? The longer the arrow, all right, the longer the arrow, the further it means to go. All right, the bigger the magnitude. All right, so the bigger the value, the bigger the size. All right, so for example, say we have two velocities, both of them are going to the right. Well, we point an arrow to the right. So we have this velocity number 1, but then we have velocity number 2, right? Both going in the same direction to the right, but then what about the size? Which size is bigger? Well, the one that's going to be longer. All right. And this is the idea of vectors. So we're going to be playing around with vectors on 2 dimensions, meaning on a piece of paper, basically. All right. So we said that vectors could be represented with arrows, but that is not the only way that we can represent a vector. We can represent a vector in terms of, since we deal with paper, we could represent it in terms of left and rights and ups and downs. So for this example, vector number 2 might be, let me just say, the arrow is 5 steps or 5 spaces to the right, to the right, to the right. Are there any spaces? Is it going up and down anywhere? And no, it's not. So, and 0 spaces vertically. And we could do the same for this smaller vector. Instead of 5 spaces to the right, this one might be 2 spaces. 2 spaces right and 0 spaces vertically. All right. Bam. So that's how we could represent some vectors. All right. What about the vector that is it has a left and it has a bit of a right. Perhaps this vector that we looked at in terms of the example with where do we go into tree. So we would say that this vector now pointing in direction the tree. So we're looking at the distance. We're gonna say, all right, guys, the tree is about, if we are all standing up on this paper, this looks about maybe 1, 2, 3, 4, 5. Let me just call it 7 spaces. All right, spaces. Space, I mean, like, imagine if we had this thing just cut up like this. 1 space, 2 spaces, right? So we say 7 spaces to the left And how many spaces up? That looks also a little bit more. So we call it 8 spaces um, up. All right. Bam. And then we have this arrow, right? So we go 7 spaces to the left. 1, 2, 3, 4, 5, 6. We're starting here and we're pointing 7 spaces to the left. 1, 2, 3, 4, 5, 6, 7. And then 8 spaces up. Bam. That is our arrow that we get in. That's our vector. All right. So the vector has a start, it has an end, and the end is pointing in the direction of our interest. Okay. So with a vector, we could express the vector as the arrow, or we could express it as 7 spaces. We could express it as spaces to the left, to the right, and spaces up and down. All right. So remember, these are conjoined together. Now, inside this lab, okay, yeah, inside this lab, we are going to be taking spaces left and right, and we will be reconstructing arrows, basically. All right. And then we'll be finding the resultant vector, and then we would be taking that resultant, and we'll be getting the spaces to the left, to the right, as well as its magnitude or the length. So where are we going with this? All right, bear with me as we proceed. All right. So let's look. First and foremost, we got vector A. All right. Vector A is the first letter. The first number here is going to be the spaces to the left or to the right. If it's negative, it means it's going to the left. If it's positive, it's going to the right. All right. So this is moving to the left. This is moving to the right. Now it says the first number here for vector A, VA, is 0. So it's not moving to the left nor right, but it's moving 3 spaces. Now this second number is the vertical axis, so this is going to be up or down. Up is positive, down is negative. So if it's positive, if the second number is positive, it means it's going up. If it's negative, it's going down. So um basically that's our convention. So we start one place, we are moving 0 spaces to the right or left, we're only moving 3 spaces up. Bam, this is VA. So you should be able to draw that. VB, what does vector VB look like? 5 spaces to the right. This is what VB looks like. All right, and this is diagram number 1. Number 2, well, this is not finished, right? These are, I'm just drawing these vectors. We need to learn how to add them together. So vector A now, it is 2 spaces to the right. So we starting here, we go 2 spaces to the right, 1, 2, and then it goes 3 spaces up, 1, 2, 3, bam. All right, this is our vector VA in the second one, and VB is 3 spaces to the right. So we start here and we go 3 spaces, 1, 2, 3, and then we go 5 spaces down, 1, 2, 3, 4, 5, bam. Now, there's something I want us to be mindful of. When we start a position, you don't count the starting position 1. If I tell you to take 1, if I tell you to take 2 steps, you don't start your 2 steps with the place that you're standing up at. You stand up with your feet together, and then you take your first step, you take your second step. So you take 3 steps, so your feet together here, bam. So if you can imagine your feet together, you don't count that as nothing. Then you take your first step, 1, your second one, 2, your third one, 3, bam. All right. And then you bring your next foot here. Right. You don't count that step because your next foot right there. So then you reposition and you come down right here on the next point. Right. Bam. And then you start counting again. All right. So now position your feet at. So now both your feet are together in your new location. All right. Your new feet together. And then you put 1 foot, 1, 2, 3, 4, 5, and then you end there. Bam, 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 bam. So be careful when you're counting. All right. Number 3. All right. We just go through it to number 3. So now the next one is 6. 6 to the right. So you start one position, feet together, take 6 steps. 1, 2, 3, 4, 5, 6. Bam. 6 steps. That's VA. All right. VB for this one, you start here. Then you take 2 steps to the right, 3 down, 1, 2, and then 3 down, 1, 2, 3, bam, vector VB. All right. Uh, and then last but not least, VC is you take 4 steps to the right and 5 steps up. So let me see. So you take 4 steps to the right, 1, 2, 3, 4, 5. Then you're taking your 5 up, 1, 2, 3, 4, 5. Bam. VC. Cool. So that was be able to draw these. Now, finding the resultant. So if we look at here, we can see that you have three vectors starting at the same location, and then we're using what we call the polygon method. This is called a head to tail. So this part here with the arrow is called a head of a vector, and then the next, and then this part without the head is called the tail. So with our head to tail method, all we are doing is repositioning our vectors so that they're joining head to tail. So if we look from diagram number 1 into diagram number 2, you have vector A. This is the head. Look at the head. And then what we do is we take vector number B. You legit grab this vector and replace it so that the tail of vector B is at the head of vector A. So you're taking B. Legit, you're taking B. B was once over here. B was once there. You have grabbed B, maintain his orientation, and have simply placed it at the head of um of A. So where A ends, right, where the head of A is where you will start counting for vector B. So once again, you follow the path of A, and then where A ends, you are going to be at the tail of B. So A ends at the head. All right, the head is going to be the tail of B. So then that's where you will start drawing your B vector, bam, and then you draw your C vector at the head of B, bam, boom. So let's try that. All right. So for number 1, all right. For number 1, you have vector A. So you're adding them together. So you got this vector VA and VB. So you draw the first vector VA, which was 3 steps up, 1, 2, 3, and then guess what? You draw vector B, where vector A ends is the start of vector B. Bam. As simple as that. So we start here, we went up 3, 1, 2, 3, we drew vector A, and now let's draw B. B is just 5 steps across, 0 steps up, 1, 2, 3, 4, 5, drawn across. So you got VA here, VB. Let's see if we could reproduce this idea of drawing the vectors. This one here, I'm just going to put down this number 2, 3, and then this is 3 minus 5. All right. So let us redraw this vector over on the other side. So VA is 2 steps to the right, 3 up. 2 steps to the right, 3 up. This is VA. Where VA ends, let's draw VB. And if we forget how to draw VB, where VA ends, we go, all right, we need 3 steps to the right and 5 down. So where VA ends, we start counting 1, 2, 3 steps to the right and 5 down. 1, 2, 3, 4, 5. Bam, you draw your VB. VB. All right. And then we're going to rinse and repeat. Let me just take these numbers. So you have your 6, 0. You have your 6, 0. You have our 2 minus 3. And you have your 4, 5. So let's see if we could redraw these. So this is the way that we add vectors. So you start at one location. You draw your VA. Hey, what's VB now? 2 minus 3. 2 minus 3. 1, 2, 1, 2, 3, right? And then the last one is 4, 5. So 1, 2, 3, 4, 4, and then 1, 2, 3. Yeah, I think this is supposed to be 3. Yeah. So this is 1, 2, 3, 4, 5. Bam. And you put them in VA, VB, and VC. All right, good. So we able to draw lines together. That is our task. Now, what is the last thing that we need to do? We need to find a way of getting our resultant. So our resultant, if we look at this first diagram, let me erase some of the stuff so that it gets a little bit cleaner. So inside of this diagram here now, after we've repositioned vector B at the end of vector A, all right. I'm trying to draw it as parallel as I can so that nobody can kind of tell me, a lot funny. All right, bam. So that is A, B, and C. And now this dotted line, where you look at it, this is where we started this chain of vectors. Chain of vectors means that we join them head to tail, right? The head connected to the tail, this head connected to the tail. So where we look at the start, there's the N, right? There's no vector connected to vector C, right? Because there's only three vectors you're trying to add together. So there's no vector going at the end of C. So we're C ends at the head. It could sound a little backward, but we start at the tail and we end at the head. I guess you could think of it as you start from the bottom and come up. You start at your feet and then you end at your head. All right. So we starting at the feet, right? We starting where the feet are, and we going all the way on up to the head. Bam. And where the feet is for the resultant vector, when we add them all together, the resultant vector, the feet should still be at the bottom here, and then the head will be where everything ends. All right, so I'm gonna draw that in a different color just so that you could try and see it a little bit more. And the head is not out here. No, it would be a big issue if you come and put it like this. Don't go and do like that. That is not the correct thing. That is drawing it backwards. All right. You do that, you're going to lose your marks. All right. So if you think of it as well, think of it as maybe an object you push from one location, you push it in A, then you push it in B, then you push it at C. It was previously at A. So we ask, hey, where did we start pushing? We started pushing from location, from the origin. Where did it end? It end over here. So what direction did we push it? We push it in that direction ultimately. It ended up over there. You will not point it in that direction and say, hey, that's how we push it. No, we started it here at the beginning, and then it ended up getting our final position C. So the arrow direction should always point to where did you end up? Where was your last vector? Where was the head of the last vector that you drew? That's the question that we are asking. Where is the head of that last vector? So with that said, we with these diagrams, we start at the beginning and we ask ourselves, where is the head of the last vector that we drew? Oh, the head is over here. So we need to draw a line from the beginning to the head, and we're gonna point in that direction. We're pointing in that direction. All right. So we started at our origin, we started here, and then we move up, move across. Bam. And we're going to rinse and repeat. We look at where we started. Where did we start? Then we ask ourselves, where is the head of the last vector? That's the head of the last vector. Let's draw a line connecting the two. Bam. All right. And then finally, we started here. Now, where's the line of the last vector? Where's the head? The head is over here. So all we need to do is draw a line connecting the two. Bam. The heads of the vectors, or the resultant vectors, are drawn. All right, now the coordinates. To get these coordinates, all you need to do really and truly is add them together. Add the x's and add the y's. So let me see. So in this first calculation is asking, when you do this calculation, I'll also fill this out. So in this first calculation is 0, 3, 5, and 5, 0. And then the resultant, these are the coordinates for the resultant vector, which is 5, 3. So the resultant vector is going to be, we have 5 is going to be 5 spaces horizontally, right? 1, 2, 3, 4, 5. And it's going to be, so 1, 2, 3, 4, 5. And then we have 3 spaces up, 1, 2, and 3. And that's how we end up getting this VB. So for those who are unsure, what we also did, or another way of expressing this, is simply, you see these, the first numbers. Remember, the first numbers we say is the left and rights. You add all the left and rights together. So the first number is the left and right. For B, this first number 5 is also a left and right. So you add them together. So you get 0 and 5, 5. And then what about the ups and downs? 3 up, 0 up and down, 3. Bam. And you go down the road. So for number 2, you have 2, 2, 3 plus 3, negative 5. So you have 2 and 3. You add those together, you get 5. And then you add 3 and negative 5. You add those together, you get 2. All right, bam. So this should be 5 and this should be 2. And when I just double check, negative 2. Sorry, my bad. I cannot add. So this is negative 2, right? So this is negative 2. All right, so then when we check this, we look at this. Hey, for image number 2, this is 1, 2, 3, 4, 5 to the right, and 2 down. 1, 2. Bam. All right. So mind you that these are supposed to be touching. These supposed to be, do not mind my inaccuracy right now. These are supposed to be perfect, right? It's supposed to be perfect. Where that ends, that's supposed to be perfect. Don't come and give me no diagrams with a arrow that like, don't come and give me no diagram, not arrow that point here and then the other one, or you do like this, all right? And then you resultant start here and then it stop short or it go over. No, none of that. Precision, 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 precision. Good, fantastic. All right, let's move back across. Um, let's move back across. So now this last one, let's just see. So we need to add some numbers together. What are these numbers going to be? So we got 6, 0, 2, -3, 4, 5. Bam, 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 bam. 6 and 2 is 8. 8 and 4 is 10. So you got 10. Wait, what? I can't add. 6 and 2 is 8. 8 and 4 is 12. Come on, man. All right. Um, so we have 12 horizontally. And then vertically, we got 6, 0, and -3 is -3. -3 plus 5 should be +2. So we got 12, too. So we should see a vector that is 12 to the right. That looks like my 12 and looks like only 2 up. Bam. And that is how we find our coordinates. So everything should match back up. So if you're not sure if you drew it correctly, all you need to do is looking at that blue line, we say, hey, we started here, and make sure when you count to get to the end, you gotta count 12 spaces going to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 2 up. 1, 2. Perfect. Perfect. Now, as I say, this needs to be precise. This one, my drawing is not looking as precise as it should. So let me just give you an example of the precision. Bam. Don't mind, I'm supposed to connect. All right. No. All right. No. Yeah, look at that. No, that is better. No, that is better. Okay. So that is how we could check. Let me do a little check for time though. We got a little bit more time. We got a little time. All right. 8 minutes. I know this one's going to be long. Anyways, the magnitude. The magnitude is going to be what? No. Take a ruler and measure the length. So we coming over here, pull this out. We say, hey, let me take a ruler and let's measure this length. So you take your ruler, you hook it up good. You look for the 0, you start your ruler at 0, bam, you measure the length. I'm not sure how long this is going to be, right? We could do a calculation, but I ain't doing it. All right. So you measure the length. Then, so you measure your length, you fill in your length inside your magnitude. Bam, 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 bam. I'm not sure. Supposed to be. Then the angular direction. I could do a calculation for the first one. Then what you can do is that you can take your protractor. You can take your protractor. Put this protractor in this color, and you're just going to. So let me take this one again. All right. So so to find the length, you know what you gotta do. All right. To find the length, we say all we doing is I just make it big, right? I'm making it big for. All right. I want bigger money, is it? All right. Let me get a little cleaner area, right? Just to avoid distractions, right? And so that we could focus nice. So once again, the length, You use your length. To find the length, use ruler. Sorry. To find the magnitude, right? To find the magnitude, you're gonna use your ruler, and then to find the angle of direction. All right. What you need to do is we put on one side, and we're gonna get a protractor. All right. This is what the protractor looks like, and the center of the protractor, you're gonna align over here at the start of your vectors is 0. Yeah. So it's gonna be a flat one like this. All right. And this is going to be the semicircle coming around. All right. And so it's cross, and then you're gonna read off this value. You're gonna read it, and you're gonna read it good. And when you read it, you're gonna get your value. So I am going to just give you a sample reading, just so that you know if you're doing it right. Um, let me see. Um, so that is 3. This is, so I'm looking at so this is going to be 3, and then this is going to be 5. So I'm gonna show you all it. I'm gonna show you all what I'm doing. It would be of decent benefit. All right. So I think the vertical. So this looks like a right angle triangle. The length is 3. The the vertical height is 3. This side is 5. So on this side is C, and I know Pythagoras' theorem. So I know that the square root of 3 squared plus 5 squared. So the square root of 9 plus 25. The square root of um, 9 plus 25. What's the square root of? When we add these together, we get 34. So you should be getting square root of 34 should be 5 point something. All right. Let me see. So if we take the square root of 34, 34 square root is 5.8, right? So you should be getting around 5.8 centimeters for the length, and for your angle theta, I know that if you're making that our angle, then I need to redraw my triangle a bit. So if I'm making that my theta, all right, so this is, so if that is now our theta, this is the way that we would draw a triangle. So I'm looking at this side and this side, and this is 5 and this is 3, and now we are interested in this bottom angle. So this is going to be tan inverse opposite, which is 3 over 5. That is going to be tan inverse of 0.6. So does my calculator have that standard? Oh, scientific. So trigonometry. So I could do tan inverse of 3 divided by 5, raised 0.6. And I want tan opposite over hypotenuse. Right. Opposite over hypotenuse. Opposite over hypotenuse is tan theta. Right. So I want tan inverse, second function, tan inverse of that. About 30, I have 30.9. So you should be getting around 31 degrees. All right. Let me see if I got any more time. Ooh, time is already up. So guys, I have 10 seconds. So that would be it. And I will see you in the next one. Later.